Hello everyone, this side Dr. Nitin Sharma from Akgec Engineering College, Department of Information Technology. So today I am just going to discuss about introduction to finite automata. So during this lecture we just discuss about what is finite automata, what is deterministic finite automata, how we can represent our automata, how we can design automata. So these are the topics which is basically discussed in the initial level. So like before starting automata, we have to understand what are the key terminologies are used when you are going to design a finite automata. Okay. So first thing is the alphabet. So what is alphabet? An alphabet is any finite set of symbols. So like when we are designing a machine, or we can say that we are going to design an automata which accept basically a string, and a string is basically made by the collection of alphabets, or alphabets is basically finite set of symbols. For example, like we can just say that ASCII code, Unicode, 0, 1, binary alphabet like ABC. So these are the examples of the alphabet is any of a set, right? What is a string? So the set of a string over an alphabet, like sigma is the set of list, each element of which is a member of sigma. So like a sigma is basically, we can say that the input symbol, or we can say that the alphabets which you can use and create a string. And a string, like we can just introduce here sigma. So sigma is like basically a comma b comma c. So these are the basically the symbols, or we can say that the alphabets. And by using of these alphabets we can just create a string. So like a string is, for example, ABC. And what are the condition of the string is, a string show with no commas. Like if I can differentiate between two strings, so like there is a string ABC comma CB comma AB comma AC. So there are, we can say that there are 4 strings. Okay, so every string is basically separated by comma, but we can say that ABC is, this ABC which belonging to sigma is called the alphabet, and this ABC is a string, right? And sigma star denote the set of string, like a set of string which is having a multiple set of strings like this. So this is basically the sigma star, right? And what is epsilon? Epsilon is a symbol which we are going to be used in our, when we are going to design a finite automata. So sigma epsilon is a stand for the empty string, like string of the length 0, like when there is no length of the string, right? So like a blank string. So blank string is represented in automata by using of this symbol, that is epsilon. Understood? For example, so for example, I will take an example like 0, 1 star. What is 0, 1? 0, 1, I already told you that is basically a sigma. Sigma is, these are the alphabet, or we can say that the symbol. By the using of these symbol you can create a strings. Okay. And what is star means? Star means a combination of 0, 1. So by the using of 0, 1 you can create a string for any length. Like you can see epsilon is when there is a no string, length 0. One string is 0, another is 1, another is 00, 01, 10, 11, 000, 001, and so on. So this is the way you can create a any kind of a string by using of this symbol, and that string is having only 2 symbols, that is 0 or 1, and the length can be anything, right? 0 as a string and 0 as a symbol look the same, like both are look the same. Like if I am talking about this is 0 and this 0, what is the difference between of them? So that 0 is basically represent that the alphabet, and that 0 is representing basically the string. So when we are giving any string to the machine, so this 0 should be given, and this is working like a string which is accepted by the machine, or we can say that the rejected by the machine. It's totally depend on the behavior of the machine. That particular machine is designed on which kind of problem you are creating. Okay. Language. So language is basically a subset of whatever sigma star for the some alphabet. Like suppose there is a string, we can just example, for example this one. So for this you can say that the set of a string of which 0 and 1 with no consecutive ones. So this is basically the language, and on the basis of this language you can create the string. And the string, you can see the what example is saying that the string of 0 and 1 with no 2 consecutive ones. No two consecutive. So you can see any string, there is no consecutive one here. So that kind of a string, when you are going to design an automata, that automata must follow that constraint, or you can say that whatever the language is given, the automata should accept that kind of string, and all other string should be rejected by that machine. Got my point? So like this is the example. So suppose I am giving, so you can see this is the string which is having a two consecutive ones. So that kind of string is not acceptable by the machine which you are going to create for this particular language. Got my point? So I think you must be understand till now what is alphabet. So by the using of alphabet, you can create a string, and that string, like a language which is basically a set of some string, right? So a language basically a set of string which is given by us. So that kind of example you can use, or that kind of problem you can use, create a automata machine. What is deterministic finite automata? As the name suggests, deterministic, where you can have the finite number of state, right? So like the formalism of defined language consists of, so basically a finite automata machine is basically having a 5 tuple, which I explained here. So one by one we can see here. So every machine like M is equal to is defined by the 5 tuples. These 5 tuples are like one by one you can see here. So first tuple is basically the Q. Q is basically a finite set of states. So like a machine is having a multiple states, right? If I am talking about, I'll take an example. Suppose there is a ATM machine. So whenever we are going to a ATM, so every ATM machine is in a initial state, right? So initial state, you can see when we are going to a ATM, so a machine is giving a we can say that a message like welcome to the XYZ bank, okay, and this is demanding an input. So whenever a string is given as an input to that machine, like a ATM card, so through the ATM card, after then we can put our pin. So these are the input symbol or the input strings. So they are taking an input string, and from one state to the, it is going to the other state. For example, this is a initial state, we can say that the welcome message, right? After giving the input, it is basically go the different state, right? Like suppose we are giving the correct pin, it is going for the another state, another some options are there. If I am going to the wrong pin, it is basically going to the, like you can put the again go to the welcome message, right? When we are going when giving a pin is correct, then going into the different path, like you want to be withdraw, okay, so withdraw, you want to be check the mini statement, okay, another state we can say change password. So these are the different state, right? And after done whatever you want to be done, at the end of it is basically giving a thank you message, thank you for using this ATM, right? So this is basically an example. So in this machine you can see that there is a initial state, there is a multiple intermediate state, and the end state. So they are the different state in a single process or in a single machine, okay, right? So similarly a machine is basically finite number of states. So these are the state basically set by representing by the capital Q. What is sigma? Sigma is basically the input symbol. So input alphabet, basically what are the input alphabet, you can use it, right? So for example, you are going to create any problem, like you have to create a machine, or you have to create a finite automata machine which accept the string which end with 0 and start with 1. So there are two symbol, you can just create any string by using these alphabet. The machine is accepted only those string which start with 1 and end with 0, and the all other string should be rejected by that machine, okay. So these are the input alphabet. Next is transaction function. So transaction function is like at any state, right? If you are in this state, and in this state whatever input you are given, so that particular given input here, it should go to the next state. So from one state to the other state, in which input you are going to going from one state to the other state, that is basically defined by the transaction function. There is a start state, as I told you earlier that every machine is having a basically initial state, so that is called here the initial state or the start state, which is represented by the Q0, and other is basically the final state. It is also a part of that set of state, and final state, just like here I am showing you that the thank you. So whenever the string is given and the string is basically going from the machine at the end of the reading that particular symbol, the particular last symbol, it is reached to the final state, that is called as the string is acceptable by that machine. Okay, final and accepting are the synonyms. So whenever I am talking about the final state or the acceptance state, they both are basically representing the same thing. So these are the 5 tuple. When we are creating a finite automata, these 5 tuples we are going to be used here. Okay, so transaction function is basically take the 2 argument, as I told you earlier that. So you can see here the transaction state function is representing basically the 2 symbol. First is the present state, like delta q comma a. So that q is basically represent the present state. So like in which state right now I am here, that state is particularly written here. And what are the input symbol? That is basically the input symbol, and that is given basically to the next state. So right now I am in a q1 state and I am taking a input a as an input. So when q1 is taking a input a, it going to the next state, that may be the q1 or q2 or q3, whatever state it is. Understood my point? So basically the transaction function is represented like this: q, present state, any sigma symbol, or it's give to the next state. So this is basically the way to represent the transaction function. Got my point? So the graph representation of a DFA. So graph is basically just like the similar other graph you have already knowing, like in a data structure or in a design analysis and algorithm. So graph is basically having a 2 things. Okay, first is the node, and next is the connection edges. Okay, the arc, we can say that. Okay, so these arc is basically directed, graph is always a directed, like, and these node are represented basically the state. Okay, so nodes is basically represent the state and arcs represent the transaction functions. Okay, so like for example, for this example I can just assume that suppose this is q0, this is q1, this is q2, this is q3, and suppose this one, and this is basically a directed graph. Okay, so this one is a directed graph, and I am just writing only one function. So one transaction function I can explain here. So how this arc is representing a transaction function, that particular. So right now I am in current state q0. When I am giving an input a, so we just go to the q1 state, right? q0 take the input a. When we are going to give in an input a, so q0 a is going to q1. So this is the way you can represent a transaction graph. Okay. Okay, so this is the example you can just see here. This is basically a example of a graph of a deterministic finite automata which accept all the string without 2 consecutive a. Okay, so this graph you can just understand how we can design a finite automata. We can just solve some example, but before this you can just understand the graphical representation of a deterministic finite automata. So here one thing is missing here, that is arrow. So when a state is basically represented by the circle. Okay, so circle is representing state, and you can see there are 2 double circle here. Okay, so 2 double circle is basically representing the final state. Okay, so single is, this is also a state, this is also a state, this is also a state. All 3 are basically a part of a state, but this double circle is basically represent the final state. Got my point? And this arrow, when a single arrow is represent here and there is no input symbol is there, you can see all other arrows are having some symbols, right? But this arrow is not having any symbol. So this is basically represent that a is also an initial state. So a state can be initial as a final as well as. And one more thing, initial state is only one in your graph, but final state may be more than one. So like in this example you can see that there is 2 final state here. So in a graph you can see there are more than one final state, it may be, but initial state it's only 1. Got my point? And if I'm talking about the that 5 tuples which I discussed earlier, so suppose I want to represent capital Q. So capital Q is basically A, B and C. These are the set of state, right? Next is sigma. Sigma is basically the input symbol. So whatever symbols you are check here, so there are only 2 symbols, 0, either 0 or either 1. So there are 2 input symbols. So I can just write here sigma is equal to 0 and 1. Another is initial state. So Q0. So Q0 initial state. Initial state I told you earlier, whenever a single arrow is there, there is no input symbol, that state is basically defined as an initial state. So A is the initial state. And what is the set of final state? Set of final state is A comma B. Why this? Because these are in 2 circles. So whenever a state is represented by a double circle, it is represented as the final state. Now I am talking about the transaction function. So transaction function, I told you earlier that. So for example, this one, this arrow is representing a transaction, like from A state it's going to the B state. So that is a transaction phase. So what transaction function they are working on it? So I just write only 1 or 2 transaction function here. First one is this one. So suppose I am going to write this one. So delta, what is the present state? Present state is A. What are the reading symbol? Reading symbol is 1. And what is the next state? It's going to the B. So next state is B. Got my point? Okay, let's take one more example. Suppose this one. Okay, so the current state is A, reading symbol is 0, A 0, and then come to A. So then A. It doesn't mean that when a present state is taking an input, it must go to the next state. Next state means is basically going to the next phase. Okay, so like when A is taking A, it's go to the B. When A is taking 0, it's come to the self state. So it is also a correct way. Okay. So this is the way you can just write all the transaction function. How many transaction function are there? So 1, 2, 3, 4, 5, 6. So total 6 transaction function are there. You can write other 4 also. Okay, as a practice. So I think the graph of a DFA, how we can represent a graph. So whenever I am going to explain this is the graph of a particular finite automata, you can easily understood that. How you can represent your finite automata through the table. So table you can see here. This is basically the input symbol 0 and 1. This is basically the state. So ABC total states are here. When A is taking a input, next states are here. So A is basically taking 0 input, so written A here. A is having a 1, then B here. Like I'll check here. If B is taking a input 1, then go to the C. So let's check the graph. So B is taking 1, go to the C. So this is the way you can just write the table here. Okay. And in this graph, you can see the single arrow is basically written on A. So this is basically represent A is the initial state, and this star is basically represent that these are the final state. Another way you can also represent the final state is that you can just write a single circle. When you are writing here present state, that is basically a present state here. So on the present state, when you are writing A and B, so you can just write a single circle. So single circle is also represent that this is the final state. Got my point? So this is the way you can just represent the. So there are 3 ways to represent automata. Either you can represent by the tuple. There's that 5 tuples you can use to represent a finite automata. Either you can represent by the using of graph, or either you can present by using a transaction table. So there are 3 ways to present automata. Extended transaction function. Sometime when we are going to solve this, so like a transaction function is like delta q wa. So wa is basically a string. Okay. So for example understood q0 and string is 001. So that is basically extended version. What does it mean basically? So initially you have to be solved like q0, take a 0 input. What is the next state? When the next state, suppose q1, then the remaining state is 01. So this is the way you can just travel it. Okay. Or another way you can just say that q0, suppose 01. Okay. Delta q0 So this is the way you can just solve it line by line. Like you can see here, delta QWA. So delta QW comma A. Sorry, this one is wrong. So this one is right. Okay, got my point. The another example like X, Y, Z are string, A, B, C are a single symbol. So extended version you can just solve one by one. So just like this, Q00, then Q101, then next again you can solve Q10. So Q10 is suppose that Q2. So Q21. So this is the way you can just solve if you are having a string here. Got my point? This is also an extended form, that particular. You can see delta B011. Okay, so what they have done, delta B01 comma 1. So now we have to be solve this phase. So this is basically a recursion portion. This is I am taking here. So again delta B01. Again I am going to solve this. So you can see the C is the right answer when we are traveling the entire way. Or we can just take an example. Suppose delta B011. Sorry, B011. Okay, so B0 is A. So delta A11. Remaining string is 11. Okay, so this is also a easiest way. Next, A1 is B. A1 is B. So delta B1. Okay, finally B1 is C. So the answer is C. So you can see also C is here. Okay, so this is the way you can just accept the string by using extend delta scheme. What is language of DFA? I have already discussed about what is language. So automata is of all kind of defined language. Okay, so like context free language or context sensitive language, regular language, all kind of defined language. If A is a automata, LA is basically represent the automata language. L for language, A for automata in its language. For a DFA, LA is the set of string labeling path from start state to the filing state. So DFA basically a set of string labeling path, like from you can travel from initial state to the end state, and that particular string is accepted by that machine. Okay, now understand some examples. Now how we can design a finite automata. So first example you can see here. String 101 is the language of the DFA below start at A. So A is basically the initial state. I have already. So you have to be design a automata which accept a string 101. So suppose I am giving a string 101. So you can just see traveling here 1, 0 and 1. After completing the path, you just reach to the final state. So that means that string is accepted by that machine. Got my point? One more example. You can see the example is here. So like 1 is giving here, whenever input 1 is given 1. So 1 travel starting from A to B, then giving 0. So 0 is here. Now the string 10 is completed. Next 101. So now 101 is completed. Finally you reach to B, and B is the final states. So that means that string is accepted by that machine. Got my point? So we can say that the set of string of 0 1 with no consecutive ones, we can say that. Now let's solve some problem. So for example, design a finite automata 01 which accept the string. We start with 1 and end with 0. Start with 1 and end with 0. So you can see start with 1 and end with 0, right? So when a string is given, so end is 0. So that means 0 can be added at the end. If I am taking here, right, like suppose 1 as a self loop. If I am writing here 1 as a self loop, so what will happen? String is 101 is also accepted here, right? So 101 is also at the final state. So that means that string is accepted by that machine. So that is wrong. It should be accepted only those strings which start with 1 and end with 0. So every string which end with 0, it should be accepted at the final state, right? Whenever a string, right now the solution is this, at the end is 1, so it is again come to the intermediate state. So whenever a string is having end with 0, it is going to the final state, otherwise it is into the middle state. Got my point? If the string is start with 0, so you can see it's given a condition that start with 1 only. If it is start with 0, So Q0 is basically asking for the 0 input, and there is no transaction function here. So that means we are not going to transcend into the machine, right? So that string is also not acceptable by that machine. So we have to be create that kind of machine, whatever problem is given, like this problem. So whatever problem is given, it is accepted by the machine, and all other string which is not created by that language, it's rejected by the machine. Got my point? Next example. Okay, so accept even number of 0 and even number of 1, right? So like I have taken here a initial state, that is Q0. I just forgot write the arrow here. Okay, so even number of 0, even number of 1. So like I have taken our string 1 0 1 0. So you can see even number of 0 and even number of 1. Okay, so I have go. Okay, so 1 0 1. I'll just draw later on. Okay, so I'll see this one. So design a DFA for W is a string that does not contain consecutive ones. So this is basically a very special question, like does not contain the 3 consecutive ones. So 3 consecutive ones, so how you can created it, does not contain. So whenever this kind of question is come into your exam, like does not contain the 3 consecutives one, so what you have to do, first you have to create when 3 consecutive one occur in a DFA. So like this one. So you can see whenever 3 consecutive ones are coming here, it's end to the final state. So like this is the final state. So whenever 3 consecutive one is occur, like 1 2 3 3 consecutive ones is occur, it is go to the final state. What you have to do, because we have to be created just reverse for this, when does not contain 3 consecutive one, but why, what I have done here, when 3 consecutive one is designed. So once you design, you just reverse the process. Reverse in the sense, like final state is become a non-final state, and all other state you can just write as a other non-final state. Okay, so what you have to do, this non-final state, this final state is become a non-final state, and these are basically a non-final state, we are going to create as a final state. So you can see whenever 2 consecutive ones is here, so it is in a final state. Whenever 3 consecutive ones is occur, it is in a non-final state. Got my point? So whenever this kind of questions is occur in an exam, so what you have to read, whenever does not contain 3 consecutive one, first of all you have to create a 3 consecutive one. After that you can just reverse the state. Like final state is basically a non-final state, and the non-final state is becoming a final state. Got my point? One more example. Accept the string with an even number of 0 followed by a single 1. Okay, so whenever is basically a 0 with an even number of 0. So this is also a, you can see an example. So like 0 0 0 0 0 0, whenever is basically a even number of 0. Like odd number of 0 is whenever it is coming into Q1 state. So like 1 2 3. So whenever I have reached in Q1, number of 0 is either 1 3 5 7 and so on. But when we reach to Q0, the number of 0 is even number, like 1 2. So 2 4 6 and so on. And the language is said that even number of 0 followed by single 1. Even number of 0 but followed by single 1. At the end we need a single 1, so we can just go to the final state. Got my point? Thank you so much. But before this, I just take one more example. Suppose you have to create a automata which accept only even number of zeros. Okay, for even number of 0, that's it, not followed by. So even number of zeros is like that. Q0 is the initial state, Q1 is the intermediate state, 0 and 0, and this is because. So whenever you are reached here, you are having a even number of 0 0 0 0 0 0 0 0 0. Got my point? And if you want to create a odd number of 0 is accepted by the machine, so just reverse the case. So you can see here 0, so 1 2 3 like this. Okay, So this is basically the odd number, even number. This is for the odd number. On the basis of this, this is the example you have to be created as a homework. Okay, this one is a little bit wrong, so you can just check here. Okay, so what we are doing here, even number of 0 and even number of 1. So you have to be create a even number of 0 and even number of here. You have to create a two automatas, even number of 0 and even number of 1 for this. Okay, then you can merge them, so it is easily. Okay, so you are trying to solve. If you are not able to solve this problem, you can just put your comment on the chat box. I'll reply you. Okay, thank you so much.